Alright, so HSC Vectors in a day. Now obviously it's not possible to learn the whole topic of vectors in the Extension 1 course in one day. I know some students are probably thinking like challenge accepted. Maybe I should rephrase. It's not ideal to learn all of HSC vectors in one day, but if you only had a day, what are the kind of things you'd focus on? What's a big overview of all the topics in there? Now it's a new course, so unfortunately there's not too many resources out there in terms of past papers. There is a sandpaper that Nessa has put out. I'll put a link in the description below. But I want to kind of give you an overview of what you can expect and what are the key things to focus on. So let's start from, like scratch, right? So the basic stuff. The basic stuff in terms of vectors is that we have things like notation that we can look at, and we have things like when we add and subtract vectors. Okay, so adding, subtracting, and with multiplication, something I want to talk about that there's actually a few different types of multiplication when you look at vectors. The basic form is what we call a multiplication by a scalar. So multiplication in brackets I'm going to put by scalar. Now what that word means there by scalar is just by a number. And so we'll give you some examples of that later on, right? Now, moving on from the basic stuff, we have also what I like to call operations. Now you may be thinking, hey, aren't addition and subtraction and multiplication, aren't these all operations? Well, they are, but we expanded that a little bit further, okay? So when I'm talking about operations, I'm not talking about those addition or subtractions anymore. I'm talking about things like magnitude and direction, which you may have seen. And the reason why I think that these fall under operations is that when you look at them and break them down, they're actually just formulas. So magnitude, we use Pythagoras. And direction, we use tan, right? So what are other things like that? We have things like projections, there's another formula for that. But then also there is something called the dot product. And when you think of product, you're thinking of multiplication, which is true, but it's slightly different to a multiplication by a scalar, because with the dot product, what you actually get at the end is you get a number, okay? So there's a difference there. When you use a multiplication by a scalar, you get another vector at the end. When you use a dot product, you call that, when you calculate the dot product, you actually get a number at the end. So unhelpfully, sometimes they actually also call that the scalar product, because you're getting a scalar at the end, you're getting a number at the end, which is very similar to this one in terms of its name, but it's quite different in terms of the calculation, okay? Those are kind of the introductory things. There are also different types of applications. So when we have applications of vectors, we can have a few different types. Usually they're going to be applied to some sort of physical scenario. So if you do physics or something like that, you'll be quite used to seeing those kind of questions. In terms of more abstract applications, we can look at like geometry proofs, which I know students either love or hate. It's a very divisive kind of topic. And the last one is probably the most complex kind of situation out of all of these is projectile motion. So we can actually use vectors to model the paths of particles or objects being shot or launched in a particular way. So that's kind of the basic idea of all the kind of vectors questions you can ask. Now, hopefully I can just focus on the first two today so that you can get an overview of what to expect and the introductions into that.